Good. Okay. All right. Okay. Let me do this. Okay, so now we're going to look at the square root of 72. Okay. Now, if you want to find a factor of 72 besides 1 that is a perfect square, and we know 9 is a factor. And since 9 is a factor, right, and 9 is a perfect square, 9 is 3 squared, that tells us that this is not simplified. So again, let me say it again. This is not simplified. The radicand, 72, has a factor other than 1, namely 9 in this case, that is a perfect square. Okay, that's cool. What do we do next? We're going to factor. Namely, we're going to factor. So we have 72 over 9, we know is 8. So 72 is 9 times 8. And then the square root of 72 is the square root of the product, right? And because of that, we get, and from there, we get the square root of 9 times the square root of 8. You know, the square root of a product is the product of the square roots. Square root of 9 is 3, because 9 is 3 squared, and 3 is non-negative. So we get this. But now we have to wonder, what about this radical here? What about this square root? Is this simplified? Well, hopefully you can see that the square root of 8 is not simplified. Now, why is that? Well, look at its factors. Its factors are 1, 2, 4, and itself, 8. 4 is a perfect square. So we factor it, 8. We factor 4 out. As before, we take square roots. With square roots, we get the square root of 4 times square root of 2, and the square root of 4 is 2, so we get 2 radical 2. And so because of that, the square root of 72, it's 3 times radical 8. That was from before, which is actually up here. Radical 8, the square root of 8, we're replacing that with this, as you can see. And doing so, we're going to get 3 times 2, which is 6, radical 2. And that's what we get here. Okay. All right, so that's simplifying square roots. I actually do have a worksheet, and I'll post some examples for everyone to try. First, though, I want to go through rationalizing denominators. Okay, so it's really not that hard to do. I mean, the idea is not bad. The book actually does it as well. What the book actually does is they also rationalize numerators. I'm only going to focus on rationalizing the denominator. And to rationalize the denominator, that just means you want to remove any radicals from the denominator. And for us, when I say radicals, I just mean square roots. Normally, you can have other kinds of radicals, like the cube root, the fifth root, things like that. I'm only focusing on the square root. To rationalize the denominator, so in this case, what we're going to use is this property, that if you square a square root, you get the number itself back. So what we're saying here is if you take the square root of something, then you square it, you're back to where you started. Okay, so how do we rationalize? Well, this equation tells you what to do. Namely, if you have b over radical a, here I'm assuming a is positive, you just multiply top and bottom by radical a. Doing so, you get this, as you can see. Now, from here, using the top property, you get this. So basically, to rationalize the denominator, you're going to multiply top and bottom by the square root of what the denominator. You're going to multiply top and bottom by the denominator. And using this property, you get what you want. So here's an example of that. Namely, we have this 1 over radical 2. That's 1 over radical 2, square root of 2, excuse me. But now we're going to multiply top and bottom by the square root. So on top, you'll get 1 times the square root of 2, which is just the square root of 2 itself. Here, it's kind of like with monomials. If you have a 1 in front, you don't write it. In other words, 1 times radical 2, we just leave that as radical 2. Radical 2 squared is on the bottom, but this is a square root, so using this property, we just get 2. Okay, that's good. That's one example. Let's look at another one. Here, we have 3 divided by the square root of 5. Okay? And so what do? Just like before, we multiply top and bottom by the square root of 5. And so by doing that, we get 3 times the square root of 5 on top. On the bottom, we get the square root of 5 times itself, which is this. Okay? And of course, you get 3 square root of 5. Using the same property from earlier, the denominator becomes this. And this is what I was trying to say before. Here we have a 3, right? The 3 we do write, but if instead of 3 we had a 1, you don't write 1 radical 5. You would just write radical 5. Just something I wanted to point out. Okay, so that's that. I'm not done lecturing yet, though. Okay, let me just stop sharing this. Okay. Wait, actually recording.